Have you ever caught a snowflake on your glove and just stared at it? Each one is a tiny, perfect piece of art, and no two are exactly alike. It's mind-blowing, right? But how do these little ice crystals even form? The journey from a simple water droplet to a complex snowflake is one of nature's most incredible stories. It all starts way up in the clouds, where it's super cold. We're talking temperatures well below freezing. But water doesn't just magically freeze on its own. It needs a little something to get started, a tiny speck to grab onto. This could be a microscopic particle of dust, a bit of pollen, or even volcanic ash floating in the atmosphere. These are called ice nuclei. Once a super-cooled water droplet finds one of these nuclei, it latches on and freezes instantly, forming a tiny, simple ice crystal. This initial crystal is usually a six-sided prism. Why? 6 sides? It all comes down to the way water molecules, H2O, bond together. They naturally arrange themselves into a hexagonal or six-sided lattice structure when they freeze. This fundamental shape is the blueprint for every snowflake that will ever form. Now, this baby ice crystal starts its long tumble down through the cloud. This is where the real magic happens. As it falls, it encounters different temperatures and humidity levels. These changing conditions are what make each snowflake unique. The crystal grows as more water vapor in the air freezes directly onto its surface, a process called deposition. Think of the crystal as a growing sculpture. The 6 corners of the initial hexagonal prism are more exposed and stick out farther than the flat faces. This means they're more likely to bump into water vapor molecules. As a result, arms or branches start to grow out from these 6 corners. This is how we get the classic star-shaped snowflake we all know and love. The specific shape these arms take on depends entirely on the journey. If the crystal falls through a zone with a certain temperature and humidity, it might grow long needle-like branches. In another zone, it might develop wide, flat plates. And since the 6 arms of the snowflake are all growing at the same time and experiencing the exact same atmospheric conditions, they tend to grow in a very similar, symmetrical way. The journey down to Earth can be long and complicated. The snowflake might get tossed around by winds, passing through different layers of the cloud with varying temperatures and moisture. Each tiny change in its environment alters the way the crystal grows. A slight shift in temperature can cause the tips of the branches to start growing in a new pattern. This is why the final design is so intricate and complex. So, when people say no to snowflakes are alike, they're almost certainly right. For 2 snowflakes to be identical, they would have had to start on the exact same type of dust particle and follow the exact same path through the sky, experiencing the exact same temperature and humidity changes at the exact same moments. The number of possible paths and combinations of conditions is so astronomical that the odds of 2 snowflakes being identical are virtually 0. From a tiny speck of dust in a freezing cloud to a delicate 6-sided masterpiece landing on your coat, the formation of a snowflake is a beautiful example of physics and chemistry at work. It's a reminder that even in the coldest weather, there's an incredible amount of intricate beauty being created all around us. So next time it snows, take a moment to really look at one. You're not just looking at frozen water. You're looking at a unique record of a journey through the winter sky. Thanks for watching. If you found this as fascinating as I do, don't forget to like this video and subscribe for more amazing science stories. See you next time.